Hello everyone, and welcome to this DTU Talk, the first in a series of DTU Talks. I am Sune Lehmann. I'm a professor at DTU Compute. I would like to start by telling you all what I do when there's not a global health crisis. So I am interested in understanding human behavior based on these large data sets that we leave behind when we surf the internet, when we use our bank cards, when we use our cell phones, all these traces of data. How can we use them to understand and model human behavior? A lot of this is highly relevant for modeling an epidemic, a pandemic such as COVID-19. This is a disease that spreads on social networks, that change over time. The interventions that governments can make have often to do with limiting mobility. And the way that we can see what's happening is through looking at societal data sources like Twitter or other social media. So let me dig into some of the work that we've done. So one of the things we did in the collaboration with the task force is that we wanted to use cell phone data to analyze the mobility patterns of the Danish population. This is highly sensitive data, and so we spent a lot of time talking with the telecommunication companies and figuring out data sources that we could use that would be helpful in understanding behavior, that would be helpful in modeling the disease. And again, this is something Jonas will talk about in a minute. And so there was a lot of work trying to understand what is the right way to do this. And when I spoke to my colleagues all around Europe, essentially what we found is that we were all facing these problems of how to respond quickly, but in a way that didn't overstep and didn't move any wrong way in terms of privacy. And so we wrote a paper about it. So you see a very long author list, which is essentially all these people that have been in similar situations all around the world. And so that it would be easier for someone else to get started. We also wrote a paper that's even more focused on the privacy things. And then also in terms of moving quickly, I've also collaborated again with colleagues from around Europe in very similar situations, giving very similar advice because I'm not alone in working on these topics. We've written a paper, this is only a preprint, focusing on what are the right strategies under which the contact tracing might work. We had to work fast here in order to make it available for governments to use and use as input for these apps. So we have spent a lot of time kind of doing that, thinking about different stakeholders. So I'll give an example here of a data set that we have from Facebook. They have a program called Facebook Data for Good that provides, again, anonymized data from the Facebook platform to help people that are responding to the coronavirus. And we've gotten access to this data set. And so this is only one of the data sets that we analyzed, but since we have limited time here, I'll use that as an example. And what we've tried to do is basically to build visualizations that can be used and analyses that can be used as input to the HOPE project in terms of looking at global information that can be useful for the Serum Institute in terms of modeling the disease, that can be used as input for decision makers and governments so that they have a way to access the data. Since, you know, like if you get a big data file, it's not so easy, but if you have a nice visualization, maybe you can use it. And which we also want to help and make the data available for anyone. So if you want to go check this out, you can do it. So here is some examples with the Facebook data. And so some of the things we did was to just do stuff that looks cool. Because, I mean, if you can, you know, like with great powers comes great responsibility to also build cool data visualization. So here you can see Denmark, and you can see where people are according to Facebook. And the height of each little square is the number of people in each square. And the color of it has to do with how many people are compared to before the epidemic. This is not the most useful way to visualize it, but it looks really cool, and I recommend you go play with it. We can also build derived data. Here, for example, you can see the change in population size, and you can note that Faner is the place that has had the most influx of people. There are many more people in Faner now than there were before the coronavirus, which is also a summer-winter thing. And you can see that people have left Frederiksberg. There's no social commentary here, but maybe they have a different house to go to, something like this. We can also look at the mobility, and we can show how on the side you can see each municipality. Here I've chosen Copenhagen and Brønderslev just to give some examples. And we can also take this mobility data and look at how it's distributed across to see if are there any geographical patterns. And we can move the slider. We can see that things change over time. Mobility here also is moving back to normal. You can click on a place and see where do the people in this place commute to, where do they go to in their jobs, and you can begin, this is part of our scientific method basically, that we begin to use these to form hypotheses that we can then test with other scientific methods that are more rigorous and that we can put in papers. So this is just a fraction. There's lots of analyses trying to take these data and to draw more sophisticated conclusions on the site. Because it's Facebook, we're also opening it up, so it's not just Denmark, but the whole world that you can go and look at. So if you want to see how is Sweden different than Denmark, you can also do that. And now it's time for Jonas to talk about telco data and modeling the epidemic and his work with the Serum Institute.
Great, thank you, Sune. How does an outbreak in Copenhagen affect people in Jutland? Understanding how local seeds of virus can spread into countrywide outbreaks is essential for a country that hopes to keep the pandemic under control in the months and years to come. And to gain such understanding, we've been investigating an amazing data set of the movements of 6 million Danish phones. So there are different ways that one could imagine that cell phone mobility data could aid in fighting a pandemic. The first one might be to look at the individual movements of phones and see how they cluster up in big groups that might turn into large transmission events. But this is not the kind of analysis that we have done. In the data set that we have access to, we cannot see the individual positions of phones, and we cannot distinguish between different individual phones. Instead, we've been looking at the large-scale mobility patterns of these phones in Denmark during the crisis. So the dataset tells us how many phones moved from one municipality into another on each day. And although this kind of data does not tell us anything about transmission events or large gatherings of people, it can be really helpful in understanding the pandemic. And during these next couple of minutes, I hope to convey why this is so. And to understand why mobility patterns are important when fighting a pandemic, we need to think like a virus. Here I show a map of Denmark on the left-hand side. And let's imagine that we want to understand the risk that a virus might spread from Aarhus to Bornholm. As humans, we see this trip as a 361-kilometer car ride. But the virus doesn't see it this way. The virus doesn't care if it travels by car or by bus or by train or by airplane. The favorite mode of transportation for a virus is a human. So in order to understand how the virus could move around in the country and spread, we need to stop thinking about the Danish municipalities as separated by these physical borders, and instead think about Denmark as being a large abstract network of municipalities where the roads connecting different municipalities the length of these roads is not measured in kilometers, but instead by the number of people connecting these municipalities. And the length of this effective distance between municipalities becomes shorter if many people travel between the municipalities, because this would give the virus more opportunities to spread between these municipalities. And to realize and understand this difference between geometric distance and effective distance, it might be helpful to think about two large American cities like New York City and Los Angeles. These cities are located on different coasts of the US, so the geometric distance is big between the cities. But they also have major airline hubs. So many people travel between these cities by airplane. So to the virus, it might not seem that these cities are very far apart. The effective distance between them might be small, actually. So in order to understand how the virus spreads and how a local outbreak affects the rest of the country, we need to understand Danish mobility patterns. But this is difficult because the epidemic affects how people move around, and in turn, how we move around affects how the epidemic spreads. So it's a complex system, but it's a complex system that we need to understand in great detail. So in order to obtain such understanding, we've done some research which can be divided into two different tracks. The first track focuses on just analyzing Danish mobility data during the crisis, and the second one focuses on incorporating the mobility data directly into epidemiological models that can be used to simulate the spread of the virus across the country. So let's talk about the first part first. So here I plot the total number of trips that we see in our data as a function of time. We see that, for example, in February, we have these nice weekly oscillations of trips, meaning that people are more likely to travel on some weekdays than in others. And suddenly on March 11th, the total number of trips just crashes. And this is when the Danish Prime Minister informed the public that schools and some workplaces would have to be closed down for some time. And ever since then, the number of trips has been increasing steadily. We can get more information out from this data set, and one way to visualize this better would be to plot the number of trips relative to what one would have expected if there were no coronavirus, for example, compare it to a February baseline. And one could also divide the kinds of trips that people make into two different categories. For example, trips that take place entirely within one municipality and trips that connect different municipalities. And if we plot this, we see that both of these kinds of trips, ones taking place entirely inside one municipality and ones taking phones from one municipality to another, crash on March 11th. But that the number of trips taking phones from between different municipalities is affected much more than the local trips. So actually, Danes did not just limit how much they were traveling during this crisis, they also fundamentally changed how they traveled. So the network, the map of Denmark that the virus would see fundamentally changed to the virus. And indeed, we can try to visualize what the distances between municipalities would look like for the virus during this crisis. We can plot the mean, for example, we can plot the mean distance between municipalities located in different Danish regions as a function of time. This is the dashed black line here. And we see that when we locked down the country, or when the Prime Minister locked down the country, then the mean distance for the virus that the virus would see doubled. And ever since then, this mean distance has been declining, but even when trips were more or less back to normal, this effective mean distance between municipalities in different regions was still around 33% above the normal level. So it seems that we changed the microstructure of our mobility networks in Denmark. So the question, of course, presents itself: does this really have any impact on the spreading? And this is what we have the second research track for. So we can take these standard epidemiological models, can be used for simulating the spread of a virus in a population, and we make one such model for each municipality in Denmark. And then we let people travel between these models, between the municipalities, using the knowledge that we have from the amazing data set on Danish cell phone mobility. And then with this framework, we can, for example, ask, if we had a local outbreak in Copenhagen, how quickly would people in northern Jutland be affected by this? And if people moved around like we did during this crisis, would this happen at a later time compared to if we all traveled around like we did in February, but with the total activity scaled down? if the microstructure didn't change. And these careful first simulations shows that actually changing the microstructure of the mobility network, so changing how we all travel around, does have an effect on when such a virus would reach distant parts of the country. So just to sum up here at the end, to understand the spread of the virus, we must understand human mobility. And Danes traveled both less and changed how they traveled during the crisis. And it seems that this could have an epidemiological impact. And the big questions going forward would be, for example, which interventions would limit interregional spreading? For example, if the country had to lock down again, would it be beneficial to keep the schools open, thereby tying many families to their home instead of traveling across the country to holiday homes when things are locked down? And of course, the big question is how this change in microstructure of the mobility network impacts the spreading. Thank you.